Hello, everybody. This is Pat Comer. I'm with NatureServe. We are going to begin this webinar regarding for the Gulf Coast Prairie Grassland Decision Support Project. We have several panelists that we're going to set things up. First, Bill Bardish is going to set us up here, and then we're going to walk through different components of the overall project. Our goal here has been to engage folks who have been involved in some of our earlier planning and scoping meetings this last year and provide an update as to the progress on this overall effort and encourage further engagement of people throughout and partners throughout the Gulf Coast Prairie's LCC. Bill, do you want to start us off?
Thank you, Pat. This is Bill Bardish, Gulf Coast Prairie Landscape Conservation Cooperative Coordinator. I'm out of Lafayette, Louisiana. I want to thank everyone for dialing in on this Independence Day week, and I hope everyone has a good holiday. This is the second in a series of webinars to give us a progress report and allow the opportunity for people to ask a few questions, comment on, or suggestions on identifying priority grasslands in the south central United States, a decision support tool. This particular project initiated from a question, consideration, a concern that our steering committee identified as one of the top 10 efforts, landscape conservation efforts that they identified in 2011, and in 2013 a small forum was convened to refine this aspect of our landscape and what the priority needs were. And in 2014 a technical review team led by Cynthia Edwards, our science coordinator, developed this project proposal. The issue was conservation and management challenges to help address those threats to grassland habitats such as land conversion, fragmentation, and to develop a process by which we could better define habitat for focal species like bobwhite quail and eastern meadowlark and other grassland dependent species. So this project was initiated in 2014. The principal investigator is Dr. David Diamond from Missouri Resource Assessment Partnership, and also Patrick Comer with NatureServe out of Boulder, Colorado. So this is a dual PI-led project, and with that I'd like to allow Dr. Diamond to go ahead with that phase of the project and give folks an update of what he has for us so far. Go ahead, Dave.
All right. So I have about 20 or 25 minutes here. Do we have a mechanism for people to type in responses, questions, raise your hand or anything? You want to address that for a second? Anybody or?
Yes, let me just address that quickly. People should see a chat window that you can, and you should be able to raise your hand, and that I will know that, and that we can address questions.
All right. Currently, everybody is muted except for the panelists, I think. So, yes. Anyway, I'll go right into some of the stuff that we've done. After the planning meetings, there was one in Oklahoma and one in Texas. We decided to generate some maps, some for the whole LCC, some specific to Oklahoma and some specific to Texas, and then also do a demonstration of a dynamic decision support tool. So I'll be talking about some of the maps we've generated. First, for the whole LCC, we've got a current vegetation data layer, which was a long time in the making, and it's more or less seamless across the border between Oklahoma and Texas. we've got some issues to clear up with the border toward Louisiana for this LCC. So from that current vegetation data layer, you can pick out lots of different things. You know, you can code types in terms of whether they're disturbance and rank them, disturbance types, ruderal vegetation, ruderal juniper, ruderal mesquite, things like that. And then the thing about a classification is it's flexible that way. You can recode things, and then you can actually do summaries by county, by watershed, by ownership, and so on quickly. So that's the power of a classification versus just a visualization like a photograph. You can see a lot of things, but you can't quantify things. And then we also define grassland patches from these data, and you can define patches in various ways, and we just did the simplest thing, so I'll go into that. Then we generated some maps for limited areas. We did evergreen change looking for juniper increase in Oklahoma, and then we did some LiDAR-based vegetation modeling for a couple of areas in Texas where we looked at the digital elevation model, digital surface model to define vegetation height and density. And then we also had Native Prairies Association data for Texas, and we evaluated those data and summarized them for one county. So here's the current vegetation for the Gulf Coast Prairie LCC. This is done for all of Texas and Oklahoma, and there are interpretive booklets for both Texas and Oklahoma that help you with the methods and give mapped type descriptions and the area within the state for all the map types. And of course, the digital data are available as well. So that's a very large and important data set, I think. And then here's an example of some of the things you can do with those data. These are the extant grasslands by type that were defined there within the LCC. So you can see cross timbers and post oak. These are the grassy parts of sort of woodland, grassland, alternate type vegetation. And you can see the Grand Prairie, the Osage tallgrass, and so on, all the way down to the Gulf coastal sand sheet there in the very south, which occurs on deep sands in the far southern part of the LCC within the U.S. Here's another example. Ruderal types, these are basically woody types on prairie soils in places where you wouldn't expect woody type vegetation. And red is deciduous and green is evergreen ruderal types. And what I wanted to point out with this is the abundance of the deciduous types and not very much evergreen types. So juniper increase within this LCC is not as much of an issue, I think, as the increase in deciduous woody types. And so map vegetation can be summarized and evaluated in different ways. This is just a reclassification or recoding of types that are ruderal. You could do this in various different ways. The orange over here, the orange here is mesquite mainly. The purple is cropland, and the gray is urban land. As I said, we still have some work to do to fill in this area for the LCC that's in Louisiana to create a seamless data layer there. Another thing you can do is summarize the data and form patches in various ways. These are simply patches that are at least 70% grassland within a 1 square kilometer neighborhood, which is a circle with radius 564.5 meters. So these are grassland patches. You could also do grassland woodland patches, for example, that had at least 20% woodland and at least 50% grassland and so on. So there are various ways you could summarize the data. Since these areas are at least 70% grassland, then by definition, obviously, there cannot be more than 30% cropland, for example, or 30% urban land within these patches. So you can begin to look for the large patches of grassy vegetation in the LCC. And you could code these patches in various ways. This is by type. This is just different grassland types. And you could also code them by land condition. This is NatureServe developed a land condition data layer, which is essentially defined by the distance to roads, the distance to urban lands, the distance to croplands. As you get further away from a road or a cropland, then the influence of that vegetation type, the negative influence, is reduced. So anyway, there's a nationwide land condition data layer that these patches could be coded with. And there's also, later on, Cameron will talk about a nationwide development pressure data layer that also exists. So you can see these different national data layers. So that's sort of the end of the stuff that is for the whole LCC. Now I'll talk a little bit about stuff that's specific to Oklahoma. And if you're from Oklahoma, you recognize this data layer. These are the game types of Oklahoma, which were developed by Duck and Fletcher, Lester Duck and Jack B. Fletcher, for the ODWC. And that's interesting because ODWC was also very, and Texas Parks and Wildlife, both of the state agencies were very involved in the new land cover data layers. And these characters here, that's Bruce Hoagland, Katie. Katie's last name escapes me, and my colleague Lee Elliott. They're doing field work in Oklahoma. So one of the advantages of the new data is that it's much finer resolution. So you can look at wildlife management areas and see some of the variation within them. You couldn't see it in Duck and Fletcher. This is just another area. One of the things that I'd like to point out, though, if you're looking at an area this size, like a private property or a wildlife management area, the data that we have that are originally generated from 30-meter satellite data get to be a little too coarse. Really what you want is quantitative data developed from looking at air photos and LiDAR, and I'll show some of that. So my dream would be to do all of the wildlife management areas and focal areas at a finer resolution in order to provide better information upon which to base management decisions at a local scale. So go into that. Here's a change from 1987 to 2014 in the footprint of 2 satellite images, the thematic mapper images in Oklahoma. This is the increase in evergreen, and this is the pines. These are Ouachita Mountains. These are the arbuckles over here. Red is loss, and green is increase. So you can see quite a bit of increase in evergreen and quite a bit of area where too much cloud cover occurred where we couldn't do this analysis too. That's these blank areas here. This is just an example of the kinds of things you can do. And this is the results in one area. You can see there is significant increase in evergreen. That's junipers in some of these areas, although not massive increases, and there has been also some clearing of junipers. That's the red over here. But the real increase that you can see is in ruderal shrublands and woodlands that are deciduous, and that's the green in this image right here. Some of you from Oklahoma will notice this big greenish area here. That's an ammo dump. And it's a fairly significant chunk of area, so much so you can see it from outer space. But yeah, there are quite a few ruderal deciduous communities in Oklahoma, and fewer ruderal juniper communities, even though junipers are often focused on. This is just same data zoomed in. And the same, this is ruderal juniper summarized by county. And the reason I put this up is that the partners at NRCS and some other areas, some other agencies allocate funds by county, and data summarized by county therefore might be appropriate to help in terms of determining how to allocate funds. So this could also be done by watershed and other polygons. Okay, so now we'll move from Oklahoma to Texas and talk about a little bit about LiDAR data from Texas. We analyze LiDAR data in two different areas. In the coastal bend, basically, in the Fayette and coastal Prairie areas of Texas. And we did part of the areas at a 10-meter resolution and part at 1 and 5 meters resolution. We'll get into that, what resolution means. And these LiDAR sensors, the reason I show this is that you have to know the X, Y, and Z of the airplane in order to be able to tell what's going on the ground. And this is not a trivial process. So, you know, there's a lot of ground information collected with these data collections, and so people can figure out where the ground is versus where the vegetation is. And prior to about 2009, 2008, a lot of the collections of LiDAR were not of a quality that we would really like in order to be able to look at vegetation height. So once the data get a little older, they're of less use. So this is just an example. What you see here on the bottom, this is a flight path across a river, a big river. This is in Missouri. And this is the LiDAR point cloud data return. So right here you can see the brown is cropland, the green is vegetation. Here's a bridge. And so you can see this point cloud here corresponds with this vegetation here. The bridge right here, you can see the arches on the bridge corresponds with this area right here. And so the point here is that the point clouds are pretty dense, and you can summarize the height, for example, of the vegetation within pixels, and the pixels can be larger or smaller. So what we're talking about when we talk about the resolution of the LiDAR, it's the spatial resolution of those pixels. So it's the average height or average ground elevation within larger and smaller pixels. So this is just another look at the point cloud, and the reason I show this is that to show that there's a lot of data here, so you can get very fine resolution looks at vegetation heights and vegetation density from the LiDAR data. So we generated 10-meter digital elevation models for Wilson and Karnes, and then up north and centered in Colorado, Washington, Austin counties. The red, you can just see the patterns of the drainages there, the gray and white being lower and going up through the red and yellow into the green being higher elevation. And so if you know the elevation of the ground, then you know the elevation of the last return of the LiDAR, you can also subtract those two, and so you're subtracting a surface return from a ground return, and the difference is the height, so you can get vegetation height. So you can see areas here with some pretty tall trees. This is probably post-Oak Savanna stuff, and then quite a bit of shrubs down here. This is 1 to 3 meters down on the coastal prairie here. So this is all done at 10-meter resolution for the whole area, and we did a finer resolution look zoomed in some areas. So not only can you visualize this stuff like you were looking at a photograph, but you can also summarize the total area. So within this polygon, we didn't do it here, I should have done that, but within this polygon you could summarize the total area, for example, of shrubs from 1 to 3 meters, or within this polygon. So that has implications in terms of management and cost for management, so therefore payment to landowners for management. So how much area of shrubs do you have to clear? Well, you can calculate it very, very at a fine resolution here using this kind of data. This is just another zoom in of an area, and to show that even at 5 meters resolution, you're seeing essentially individual tree crowns with this data. And I just wanted to show you this in order to look at the difference between 10-meter resolution summaries and 1 meter. So this is at 1 meter, and this is at 10 meters. And so if you're calculating the area of shrubland, you get one answer here, and you get a very different answer there, quite a different answer. And that kind of answer could be very important for habitat quality of a given species, like quail or eastern meadowlark or whatever, what have you. So, the difference in calculation can be pretty significant depending on the input data. This is forest canopy density, and this is another thing you can do. You can see that the bottomlands have very dense forest. These uplands don't have as many trees. This area doesn't have many trees, but with the LiDAR data you can see that it has quite a bit of shrubs. So the red is pretty dense here, whereas the green is pretty sparse, so that's more of a shrubland. And then I just wanted to show you this because this is summaries of data at 30-meter spatial resolution, but remember the LiDAR was gathered originally at very fine resolution, so you can still see the senderos here that have been cleared even at 30-meter resolution. But if you look at original 30-meter resolution satellite data, you don't get the same resolution, so you can see the difference. So if you're calculating the area of shrubland, you do get different answers when you use these different data sets. So it's just really very good data. Using LiDAR is really good for defining shrub versus grass and doing habitat quality evaluations. And it can be done over fairly substantial areas as well. Okay, so this is the other area we did in Washington, Austin, Colorado counties. This is the wild prairie chicken refuge here. And these are two NABC paired areas that they're looking at for quail and looking at and prairie chickens as well, and looking at procedures to clear shrubs from these areas. This is just a little bit of a zoom in and another zoom in. And I didn't know what these things were originally. I thought they might be rice fields, but they're actually tree farms. There's a bunch of tree farms in this area. So these are little rows of trees that are showing up on the imagery. And this is just a different place. Shows some tall trees down along the drainage here, trees all along the drainage. You can see fence lines like with trees growing along them and so on. And there's another one of those tree farms. And so, like I said, it would be possible to generate some of these data, this type of information in fairly substantial areas across Oklahoma and Texas. And there's a very active data collection process for LiDAR going on in Louisiana as well. And so if you had the distribution of woody species like you can get from LiDAR, you can't combine that with ground collected data on grassland quality like Texas Parks and Wildlife is doing in this area in green. You can really start knowing the quality of habitat for various species across a fairly substantial areas. I just wanted to show you where we've already got LiDAR within this area. Colorado, and part of Colorado County, and then Atascosa, Wilson, Karnes, and so on. So all of these data are going to be made available on the Gulf Coast Prairie LCC Conservation Planning Atlas. A lot of it's up. We haven't organized it as well as we would like to. These presentations are up, and I'll let Pat talk more about that. You can access the presentation I just gave and the one that Cameron and Patrick are going to give after this. So that's all I have. Are there questions? You want to type into the chat?
Right, you can raise your hand and I can unmute you. I can unmute others if we have questions right now.
I think you will have had to type in your audio pin to get unmuted.
Uh-huh. People can also type in a chat if you want, into the chat box, if you want to post a question in writing. Okay. Okay, well, let's proceed on. I'm going to change presenters over to Cameron, correct?
Yes.
Okay, Patrick, you want to go? Want to start us off?
Yeah. Yeah, thanks, Pat. Thanks, everybody. This is Patrick Christ, also with NatureServe, and I'm going to be talking about the Dynamic Decision Support product. Next. So just as a reminder, there were these two types that had been decided through the course of the project. Dave was just talking about some of the static tool products. So this dynamic one is making use of some of those products, but what's different about it is that it's actually an interactive software tool that people can merge their own data into. They can manipulate data. They can create new analyses and new products with it. Next. So through the course of discussing what this tool should do, we came up with these two basic types of decisions, the first being proactive, where we can evaluate the entire landscape and then identify the best places for conservation investment. And in the case of, say, farm bill programs, actually work directly with landowners to see if they're interested in participating. The reactive is probably more typical, which is to have a site that has come before you, proposed for some conservation action, and then to be able to look at it in context and identify what is in it in terms of how valuable it is, what sort of things might be impacting it, what condition is it in, that might suggest what the conservation needs are, and ultimately determine whether it's a worthwhile project, if so, what the best thing is that it could provide relative to the type of investment needed. Next. So sorry for the box and arrows, but this just illustrates overall what we're trying to do. So the top group of boxes is really pointing out the inputs in terms of the habitat distribution. We're not really working, well, we're working with Bobwhite habitat and a few other grassland types. So there's a simple handful of habitats and species distribution data. And then we have stressors as well as practices and things that support the habitats. When we combine existing and expected future stressors together in that sort of tan-colored box, we can model habitat condition. And then through that, we get the map of where are the habitats and what condition are they in. And then the lower part is taking land parcels or other sites and then the existing conservation areas and calculating the proximity of all of our sites to existing conservation areas, and then being able to derive that parcel proximity to conservation. And both of those then feed into interacting with that information through the tool to do those proactive and reactive steps. Next. So we identified some different participant roles from the LCC partner group. This first part is dimmed because we've already been through the information provision. Parts of this, we're really ready to move into the system user and tester. I understand we have a couple people so far that have signed up to do this. So you can actually get this free ArcGIS extension, NatureServe Vista, and install it. We'll get all of the project data to you, and then you'll be able to run through these couple types of decisions and then report back on how well it worked out for you. And as well, we anticipate what we're calling more of a passive evaluator role, where we expect to have 1 to 2 web meetings where we and or the system user testers can demonstrate the system and walk people through it, and they can ask questions, and then they can also contribute their assessment of the value of this to the final report. Next. All right, so I'm going to turn it over to Cameron Scott now, also with NatureServe, who's going to show you where we're at with this so far.
Hi everyone, this is Cameron. So first I'm just going to do a really brief overview of the Vista tool. Some of you may have seen some of this before, but we're not going to go into quite as much depth as we may have on previous meetings. But it's a tool that was originally developed for conservation planning purposes, although it is multi-objective and can be used for planning of various types. It's, as Patrick said, a free extension to the Esri ArcMap software, and it includes fully integrated help as well as a user manual and live technical support and training if needed. A lot of this is due to the endowment that has been set up. So the tool was released first a little over 10 years ago, and since that time has continued to undergo maintenance to fix issues that have come up, as well as to add features and functionality that were identified as improving the tool. So what does Vista help you do? Just really briefly, it helps you organize and visualize your spatial data, primarily within the ArcMap tool, and then with the Vista results within the Vista tool. It helps you incorporate expert knowledge into the process so that you have some defensible basis for your results. Helps you define scenarios and alternatives to those scenarios and then analyze what those alternatives do. Helps you document decisions. Those can be both decisions based on the expert inputs that you got or the decisions that you were making in running the analyses, and those decisions show up, or any documented comments show up in reports that are generated by the tool. And finally, it helps greatly in supporting adaptive management. So that's the dynamic aspect of this tool, and as I'll discuss a little bit later, it allows you to swap out information as either new, better data is available, or just completely new data is available. So what Vista does is fairly simple. It has 2 main components. The first being elements, which are the things that you care about. So in this case, we'll see 4 elements, 2 grassland ecosystem types, 1 habitat, potential habitat element, and then 1 grassland, not remnant, remnant grassland element type. And so these elements can be things like that, or they could also be other things of interest. They don't have to be species or ecosystems. The second main component are the scenarios, and so the scenarios are the things that affect your elements, and we'll be looking at the specific data inputs that were used to create our scenarios. And we have 2 scenarios in this project, one current and then one future. And then Vista takes both these components, and in combination with your expert input on how the different scenario components affect the elements, it will run several different types of analyses, and we'll tell you kind of what the effects will be of the scenarios on the elements. And this is a decision support tool, so it's going to do a lot of number crunching, and it's going to provide a lot of different results. But in the end, the results are meant to inform decisions, not make them. And as you get those results, the Vista tool can also be used to identify goals and how close you're coming to meeting goals. And this kind of gets into the evaluating alternatives component that I mentioned. And you can try out different alternatives and see if they help you get closer to your goals or not. And we won't be looking at the goals aspect too much, but we will be looking at the data that you might be using in making that kind of process. So just to give you some geographical context, the project area we chose focused on 4 counties, Wilson, Karnes, Austin, and Colorado. And so we took those counties and we buffered them by 19 kilometers in order to make sure that we captured any impacts that were outside of the counties but did have an impact within the counties. And then the project area also includes 4 counties in between those. And so this solid blue line is the full project area that was evaluated, and you can see where it is in relation to the larger GCP region and that upper left box. So going to elements, so again, these are the things you care about. There are only really 2 main requirements for your elements. The first is that you have a spatially explicit distribution, and so that in this case means an electronic map, a shapefile or raster or some GIS layer that identifies where this element occurs. And the second requirement is that you have some known requirements. Things like how the scenarios are going to impact the elements, if the elements have a minimum size for viability, what the threshold is that the element has to persist in the presence of certain conditions, things like that. So we're mostly just going to look at the distributions of the 4 elements. But first, we have the Blackland and Coastal Prairie element. This is based on the Texas Ecological Systems Map. Similarly, also based on the Texas Ecological Systems Map is the Post-Oak Savanna element. And then we have potential Bobwhite habitat, which is a mixture of those 2, weeding out areas that have greater than 50% tree cover based on land fire data from 2010. And then finally, we have the natural remnant grassland element. And this one is based on data that is only available in Austin County. And so it doesn't cover the entire project area, but is an example of how you might have some really more precise footprint elements that you want to evaluate. So going to the second main component, the scenarios, these are the things that affect the elements. Again, one of the requirements for your scenarios is that the data that you want to be included in the scenarios needs to be spatially explicit. So you need GIS layers representing that data. And then you need, you could include scenario components that don't have any effects on the elements, but they're not going to affect the results. So in order for them to play a role in the analyses, they need to impact one or more elements. Okay, so first we're going to look at the data that we used for the current land use scenario. And there are going to be 3 different slides. You can see some of the data inputs were wide-ranging. Here we see low, medium, and high density development. These are the gray, various shades of gray in the project area. We also have vegetation condition class, which is a land fire data set, and it's used to indicate kind of the departure from the normal fire regime. We also have a number of layers that aren't quite as widespread, but are still, they still cover a large portion, a large area within the project area. You have agriculture, problematic native and non-native species, several road types. You can see they're broken out. I think that's I-10 in the upper middle portion of the project area, as well as state highways, local neighborhood and connecting roads, and then scattered four-wheel drive and dirt roads where that data was available. And finally, we have also data on things that are more restricted to specific spots. So here we have mines, railroads, and communications tower data. Finally, for the second scenario we did, we included all of that initial data that represents what's currently in the project area, but we replaced the development data that we had with projected urban growth model done by Dave Theobald with the EPA, and took the 2060 projections of development and put them into this scenario, which just gives you a way to see kind of what the threats might be down the road. And if you have projected data on other things other than development, you can include those. And so that's going back to the adaptive management aspect of the tool. These scenario inputs, they can all be swapped out for more precise or newer data at any time. They can be removed if they're deemed not applicable anymore for some reason, and new data can be added to them. And similarly, if you want to evaluate additional elements throughout the project area or in a smaller area, you can add elements to the process, and the Vista tool will take all that new data, and where necessary, it will rerun analyses and evaluations so that you can get the new results based on the same methodology, but that reflect the latest information that you have and the best information that you have. And so this is a pilot. A lot of the data we used was national and regional. It could be replaced with precise local data where that's available. So Vista takes those two main components, the elements and the scenarios, and then it takes that expert input that's gathered as part of the process on how the scenarios affect elements, and it creates a number of different types of results to show you what the impacts are on those elements. So the primary analysis that we are using and that we'll look at today is the landscape condition model, which was developed by Pat Comer and John Hack here at NatureServe. And it is intended to give you a full-scale condition of the landscape based on the elements or based on the scenario inputs. So here we have an example of a very simple scenario that just includes paved roads, water development, high-density development. And you can see that the water development is little spots throughout the area. The roads are linear, and then the high-density development is kind of grouped into blocky areas. And then we also see the two scores that are here. So the site intensity score reflects the condition that remains in the presence of that land use. So in the presence of paved roads, you have about 0.01 of the condition, or 1% or almost no condition remaining. Same with high-density development. For water development, it's 0.5. That's implying that there's about 50% of the pristine condition remaining in the presence of water development. And those scores are assigned to a model, and a model is can be generated for the overall project and used for all elements, or it can be tailored to each unique element depending on that element's response. These values are then taken and used in generating this map. So you can see again that the final results go from 0 to 1, similarly to the input scores A 0 indicates a complete degradation of condition, and a 1 indicates more or less pristine condition. And again, this is only relative to the scenario inputs that were used to create the model. Looking at this kind of zoomed in area, I'm just going to point out a few things. The score you can see, the 0.1s for this is a road here and here. There's some high density development right in this area, and then these spots are water development. You can just see that the 0.1s are represented as a 0 to 1 on this legend where they occur, and then their distance effect goes out 19 kilometers in the case of high density development, and 3 kilometers in the case of roads. So that distance effect is not, it degrades over that distance. And then the water development, which had a 0.5 condition, you can see it's in slightly better condition where it exists, and with that 1 kilometer buffer, it doesn't extend as far. And then the last thing I'll point out is just that where different land uses overlap, their impacts are multiplied together. So this is a multiplicative model. If there's one thing that's very degrading, nothing is going to bring that up higher, but the presence of multiple low impact land uses might degrade an area, will degrade an area in a multiplicative fashion. So don't worry too much about the very detailed specifics, but just that's the overall way that the model works. This is just showing that we have the inputs for the different land uses that you saw in the scenarios, and we use two different models, one for the ecological systems, and so that was for the Blackland and Coastal Prairie, the post-Oak Savanna, and the Austin Remnant Grasslands, and then we used a separate model for the potential Bobwhite habitat that reflected the idea that we weren't looking for pristine habitat necessarily, but more what areas might Bobwhite be found in. And so the scores in certain areas are scored with less of an impact and lower distances than those for the ecological systems. So we'll focus on the potential Bobwhite habitat, and this is the resulting model. So this is that 0 to 1 scale map reflecting condition in the presence of those scenario inputs that we looked at. It's been clipped to the elements distribution. So while there is a map of a full area, these are the areas where the elements distribution occurs. And so you can see up here there's an area that's very influenced by high density development, as well as over here. There are also pockets of high density development that are having an effect throughout the project area. You can see the roads network is having quite an effect at this scale. And if you zoomed into areas, you could see, kind of a finer detail of what the effects are. These results are also summarized to a site level. So for the pilot project, we used a 1 kilometer grid, and all of the condition within each 1 kilometer grid cell are averaged, and so you see an average condition map of those. For the purposes of this demo, we're going to kind of focus in on an area around the Atwater Refuge, and we created some fake parcel data. So for the purposes of, or for the intended use of the dynamic tool, parcel data is likely to be something that is most useful, and it is available county by county and could be obtained for, I think, a fairly minimal cost in most counties. And so we'll show you the demo with those parcels right here, but the tool is currently implemented uses a 1 kilometer grid cell. So I'm going to go into kind of those two processes, the reactive and the proactive. So the reactive first, we'll just think about, if you're approached by a landowner and they said that they had, about 1,000 acres, really close to the Atwater Prairie Chicken Refuge, and they were interested in getting some money to do certain practices, to try out some things and maybe create some better habitat, you could use this tool to get some information. And so if they told you that they had parcel 41, which is just a made-up ID, you could go into the tool and select that parcel and bring it up in Site Explorer, which is a tool within Vista. What this is going to do is show you the several different things summarized to that parcel, to that site, and you can select multiple sites if you want. First, you see what elements. So out of our 4 elements, we can see that 2 occur in that parcel, the potential habitat for bobwhite and black-winged coastal prairie. And we see the total areas in the project area for those, but then we also see that there's about 400 acres of each in this parcel. You can see which scenario components are affecting it and what area within that site they occupy. So there's 268 acres of the severe departure vegetation condition class, about 260 acres of crops and irrigated agriculture. You can also see that there are combinations. So because one thing we didn't really go into, but Vista is based on, it creates a raster stack for the scenario, so it can have more than one land use existing in the same area. And so here it's showing you, based on the icons, vegetation condition class of severe departure along with crops. And there are about 84 acres where those both occur. There are areas, a very small number of acres where the severe departure, local roads, and problematic native species occur. And so as many land uses occur, you'll see it broken out in this list. So you might think, okay, well, we have some things we could work with on this property. And if you look up here, you can see, going back to that condition map that we looked at earlier, there would be 2 different condition maps generated based on those 2 different models. So for the potential bobwhite habitat, your average condition within this site is 0.2, so not great. And then your average condition for the blackland and coastal prairie is 0.09, so so it's even lower than there. And if you've input compatibility thresholds, condition thresholds for the elements, which we did, we see that in this site, based on our thresholds, there aren't any areas where we currently consider the element to be viable long-term. So there's no area where the element is compatible. So you might take this information and you could use it the way that, in your decision-making process, whatever that is. But you might determine that it's not worth your pursuing because the current condition of things on that parcel are just not very good. A final thing I'll point out, it's not showing in this screenshot, but you'll be able to see the proximity to protected areas, which is currently based on the protected areas database data, but could be if you have GIS data on your current areas where you have funding for landowners to do work. That analysis, which is a manual analysis done outside of Vista, could be done and added to that site layer so that you can see how close this site is to another area where you're doing work. But so let's say that you decided you're not going to follow through with this request, but you do want to do some work in the area of the Outwater Refuge. You could go into the tool and look at the same area and pull up the condition map. This one is for the potential bobwhite habitat again. And you can see the condition of what is here. And so you see, some areas that are red that really are currently in very poor condition. There are some areas that are in better condition in the lower right and just to the west of the refuge. And then there are areas that are in this kind of in-between stage and either have some decent condition but not a lot of habitat, or have a lot of habitat but are in poor condition. So you might look at this and say, all right, I'm going to select a couple sites that I feel like would be worth pursuing. And I want to see what what's in those and what those might get me. In addition to this, you can see them summarized. So this is also through the tool, it's just a summary of those condition scores by site. So you can see that there are some large tracts with moderate condition. There's a grouping of parcels up here that have relatively good condition, some better than others. But let's say that you're looking at these two because they're in roughly, they're right on the threshold of what we determined to be the threshold for the potential bobwhite habitat, which is 0.6. So they're right in that range, and they're immediately adjacent to the refuge, so they might provide some buffer capacity to the habitat in the refuge. So you select those two sites, and you're going to get that information that we looked at for the reactive scenario, and you're going to get it for those two sites combined. Again, you see that there are those two elements. They both occur here. You can see that we have more of their habitat within the selected sites. We have a similar array of land uses, although we also have low density and medium density development, although they're very low in terms of the area that they cover within the site. And then if we look at the average condition, it's a lot better. So for potential bobwhite, it's 0.56. So that's just under our threshold. It's still not great for blackland coastal prairie, but we see that we have almost 700 acres of currently compatible land within these two sites for the potential habitat for bobwhite. So based on this information, oh, and you can also see in the selection attribute, this is the ID. You can see the proximity of each, which would be negligible. It would be 0 or 1 kilometer since they're bordering the water refuge. But you can see information on all of the selected sites. And you can select sites either manually by dragging a box. You can use the control button to select multiple sites, whatever works for your individual situation. So that's kind of the proactive process. And then I just wanted to screenshot really quickly to show, if you just wanted to investigate what was going on in an area, we have some of the land uses turned on along with that condition map. And so we see the blue areas, these are agriculture that are included in the scenario. These pink areas are problematic native species. You can see a black line coming through. That's a railroad coming through here. There's a pink line here that is a highway. And harder to see are some of these, there's kind of some like grayed out areas. This area is a little darker gray, and this is a lighter gray. And then again, here there's an even darker gray inside the medium and then low. And those are the density development. So you can see, this line is a railroad. That's what that red line condition is due to. The density development is having an impact here. In our selected sites, we can see where the problematic native species are having an impact. We can see that the density development was really kind of up in this northern portion of this one site, kind of spill over from this area. It allows you to dig into some of the details about what's going on and determine if what you're seeing is in agreement with what you know about the area. And if it's not, you can always go back and tweak the tool inputs and rerun the evaluations. And so again, that's part of the whole adaptive process. So next steps in terms of the dynamic portion, as Patrick mentioned, we have a couple people lined up to do some testing with this tool. And if anybody else is interested, please contact me and let me know that you'd like to participate, and you would just need ArcGIS and a copy of the Spatial Analyst extension. And then if there are any questions, I can take those, or I'll turn it over to Pat, and then if we have time and there's an interest, we can look at a little bit of a live demo of the tool.
Okay, if there are any questions, people can raise your hands. Let me know. I can unmute you. I can unmute everyone, actually.
Thank Lord. Man. We went around that.
Oh, maybe I better not. Can people raise their hand if they have particular questions? Okay.
Pat, Bill Bardish, I had a question for Cameron on the live testing. It may be possible for us to draft a couple of other folks, depending on who's volunteered, to participate in that as well. So I wanted to throw that out there as an opportunity to maybe request some folks, one from our regional office and another from one of the LCCs. So
great. Yeah, currently we have John Hayes and we have Bill Vermillion lined up. And so if you have additional people, just shoot me an email, and I'll be organizing kind of a meeting to talk to everybody who's interested in that testing, probably sometime next week, depending on schedules.
Very good. We'll do that.
Thank you.
Great. I'm not seeing others raising their hands. We actually, I think, would have some time to walk through a little bit of a demo if you have a chance to do that, Cameron.
All right. So, if there's anything in particular that you'd like to see more of, let me know. I'll just try to go through really briefly the tool so that you can see how it's working and how those things that we just looked at in the screenshots are in the tool. So we have the elements. This is, if you're familiar with ArcGIS, it's a pretty standard ArcGIS window frame, but we also have a Vista toolbar, and as well as in this table of contents window, there's a Vista table of contents. So you can see your normal ArcMap table of contents view, which shows you all the layers that are in your project, but you get a Vista-specific organization showing you your elements, your scenarios, the evaluations within those scenarios, and then all the different types of results. And so you can see that there's a lot of data in here, compared to what we just looked at. But right now we're looking at that evaluation map that we saw. Within this Vista navigation system, you can right-click on any of the objects and look at properties of the elements if you want to see what it is that was input as what the inputs were, so you can see the condition threshold or the compatibility, and you can see what spatial data was used. You can also look at the scenario specifically and see how that information was in, or if you wanted to change any scenario data, you can, let's say, remove FCC towers, delete that, add some new data in, and rerun it. That's generally considered to be slightly more advanced. We wouldn't be expecting you to do that in the testing, but it's pretty much as simple as going to that scenario properties, replacing the data, and then refreshing the evaluations. And so we see the just general potential habitat for Bobwhite condition map here. That's based on, let me go ahead and turn off all. Turn off all of these layers so that, there we go. That's based on a full map, which is kind of wall-to-wall, and the reason to do that is that you might have multiple elements using the same model, and so they would each clip the full model to their distribution. like I said, we on the pilot used a 1 kilometer grid. Sorry, this is the evaluation I ran on those fake parcels. So you can see that parcel data set down here. The full project area was run with a grid, that 1 kilometer grid. So this is very similar to that more specific condition map, but with conditions averaged by grid cell. And this is what this site layer is what is used to look at that site explorer tool. So let's just to quickly replicate what we did, what we saw. I'm going to turn on the data we have on the Atwater refuge. So here we see the refuge. I'll go ahead and use the grid. So, we saw an example using the fake parcels, but let's look at a grid thing. So I just right-click on the evaluation, look at Site Explorer. It's going to kick on. It's running all of these. Everything it's calculating on the fly. So depending on the size of the project or the number of cells that you select, there might be a slight delay. But you can go in here, and if you wanted to just explore a specific cell, you can click on it and see what elements, all the same information that we saw before. What elements are there? What are the land uses impacting those elements? What is the average condition of that cell, etc. It's going to take a little while because, like I said, it's running all of that, all those calculations on the fly. You can see the additional, see the land uses there. What we saw was, that we saw the average condition by the selection, we saw the selection compatible, and we saw the selected area. But you can also include a number of different statistics that are generated and look at those. You can see a report for your selected site. So if you want to share this information with somebody else who doesn't have the tool, you can click on the report button, and you get basically all that information from the Site Explorer tool interface in a report format that you can save or print and share with somebody else. That feature, that reporting feature, is pretty much available for any of the objects. So you can produce reports on elements and get all the inputs and settings for the elements. You can get reports for the scenarios, and you can get reports for the scenario evaluations. And each of those will give you kind of the metadata for what went into the object as well as the results. If we were to look at kind of a, well, I'll just show you, since we have the two open right here, we could go to that different evaluation, which incorporates the parcel layers as the site layer, these fake parcels, and we could use that to select different areas. And so you know, within the tool, you can have multiple different site layers, and you know, depending on what your purposes are. And you might want the grid layer if you're just generically looking at the landscape and trying to identify areas generically. You might look at a parcel layer if you want to identify specific landowners or specific parcels. And then you might have some other site layer that you want to incorporate. Because I didn't show it in the slideshow, I'll also show you the kind of that proximity analysis that we ran we are considering adding, so it's just a pretty straightforward distance map to the nearest protected area based on that protected areas database. If I can find it. So I think. So these are, let me see if I can actually find the ones that are symbolized. Here we go. So this is, we ran it 2 different evaluations. Because we were working with the protected areas database and didn't have any specific parcels that current work, let's say with the equip practices or whatever we're being done with, we ran this in 2 ways. One was on any protected area that was within the project area. And so this includes some military sites, it includes some state parks, and it includes areas that are designated for wildlife management. This is just symbolized in 2 different ways so that you can see clear lines and get a better sense for what the actual distance is for an area. Or you can look at it in a more seamless, a smoother progression of changes. We also ran the analysis using only the areas that are being managed for wildlife. So, you see that these areas closer to the wildlife refuge have values closer to 0. So this is in meters, and then you can get out to up to 126 kilometers away from the nearest area managed for wildlife. We're considering adding an index. It was kind of something that just came up recently, and if we have the time to add it, we will. But it would be more of an index that incorporates the concept of an area that might be near multiple protected areas. And so the closer it was to multiple protected areas, the higher the index value would be. But that hasn't been implemented, and we'll probably talk to the testers of the tool and see how things are working and get their input on the utility of that index. Any questions, or anybody want to see specifically something else within the tool, or Patrick, anything you want to add?
No, we know that's a lot to take in all at once, and so again, we can take this one bit at a time when we work with you if you're interested in being a tester. It's actually, Cameron's kind of going through everything in there, but the actual bits that you would interact with directly are pretty confined.
Yeah, don't be too overwhelmed.
Great. Thanks, Cameron. I am not seeing any hands raised with particular questions. So, like I say, I think we have been identifying individuals who wanted to represent their agencies or just engage with us further, so that there's opportunities here to dive in more deeply, get to know how tools like Vista work in this sort of a context, and that's what we very much would like to encourage through this project. So, not seeing any hands raised here. I think we might want to close out here soon. Bill, did you want to say anything before we close out this webinar?
Just wanted to thank Patrick, Cameron, you, Pat, and Dave for preparing this. I think this, we will have it, like you said, taped. It's available on that platform, the Conservation Planning Atlas for the team, and let's visit via email on drafting a couple key people with targeted agencies, organizations that we can include in this test drive. So that's it. Again, have a great 4th of July, Patrick, Dave.
Yes. Yes, same to
you.
you all.
Thanks, everybody.
Yeah, thanks for sticking with us, everyone.
Thanks
you.
very much. Happy 4th.
Okay.
Yep. Bye-bye.
All right, bye-bye.
Bye.